So when you are sending a package from one system to this system, particularly coming to this one, because this architecture I might have explained even the previous also, but once again I'll try to explain. It is one of the department of one of the organization of entire ministry, otherwise one of the department of an organization in a ministry, and you would be the part of this local area network. You may be having another department in the same organization, same ministry, which are connected or divided within an internal firewall. Today we'll discuss about what are those firewalls and all, infrastructure and all. So when you divide it into these two departments, and whenever you want to connect to a particular external network, it could be an internet. Let's say here we take example internal network is entire organization, external network is an internet. Even if we wanted to transfer a packet from your department to your sister concern department also, there could be a possibility, even though they are connected in one building, they would be divided with the internal firewall, so that that is where you transfers. So let's say you sent in a packet within the LAN, that will go to the packet to the switch, and then it will go to the another particular server. Let's say you are sending message to him, so the packet will go to the switch and travel entire to the destination. And both are, because this finance server is within the same network, both are accessing, and these packets are also going to the switch and switch to finance server, and in return finance server through switch it will come. So this is what basically within the LAN. So LAN, local area network, when it is going to the other network, other LAN within your organization, that is called intranet. Because in the same organization, that organization, within the organization, there are two LANs are there. The two LANs are together as part of the same organization. Talking LAN between LAN, maybe that is intranet, because your own network, your own organization network, your own ministry network. Am I right? So this part is called intranet. As many as departments may be there. So, but here example I am telling about only two departments. So that is where, suppose this same guy is transferring a packet to this network, this may be forwarded through firewall via the switch and to their switch, and it would be forwarding. Okay, but the same person is further going to the internet. So there is a concept of a gateway devices. The gateway is like a main door to your organization. So anybody wanted to come into your organization, or anybody to wanted to access from to your organization, or anybody from your organization to outside. So that is the way gateway that should reach, so that to forward to and get the request outside. So that is where we use gateway firewalls, external switch. This switch could be a logically connected. This router is also connected to the switch, one port, and firewall is also connected. And so packets when outside, when it is going, so this should reach gateway, and further it will forward to the boundary router to etc. to Google server. If somebody is accessing from outside, to access is one of the your, and one of the thing we didn't forget about this part. See, even though these are the CDAC, your same organization, web server, they were separated with another setup zone, demilitarized zone, DMG. Why? Because so if these servers are we are giving to the public, when anybody public is coming, because if we are open door to public. But whenever in our organization, anybody come to your main door and access and sit somewhere in the where the people outside, like a conference room, you will keep it, and or otherwise lounge, you will keep it. You will request to keep them and sit there until the one of the person comes, goes wherever he came to meet. Am I right? And similarly, if somebody wanted to access our some services, the DMG like in a launch of our organization, where we allow them to set, and whatever the things required for resources which we'll give it to, and from there itself we will send it back. Same way, so when somebody wanted to access in our email server, web server, he will come to that and through DMG, they will access and go that. In case these three systems are part of one of the network, then they can come here and they may also try to access internal machines. We don't want that. Outside member is coming and accessing my internal machine. We don't want to do that. That's what we separated this zone as a DMG, and we are hosting the services. Further, we also giving the same, even the internal member also wanted to access CDAC, he should also come through gateway firewall. Everybody should reach here, that gateway firewall, to access this side and to access this side. So to control, because if you look into the last 10 years, the most of the frauds and attacks are happen through internal system only, whether intentionally or unintentionally. So the systems, first hackers, because they can't beat these firewalls and all, they may be using a social engineering attacks, and they may be coming through by sending in a malware to the desktops, and from their desktops they may access our servers, because they cannot come directly, because we simply implemented some security system. So somebody, attacker, will target this particular person, and from there we will try to go and access. That's what. So we separated these servers as in a separate DMG. So this is where that architecture. But when packets are flowing from one device to another device, only the two addressing systems which you are using, one is MAC addressing, the second one is IP addressing. If your mobile having MAC address or not, let's check it. So go to the settings and see that your system configuration or mobile configuration, definitely there would be a MAC address. The MAC address is nothing but is integrated with your network card. If your mobile is having a connectivity, whether WLAN or LAN, so that easily this one. And MAC address is also called physical address because it's a physically attached to your network card. It is also called hardware address because it is in your NIC card integrated, your WLAN card, it is integrated. So any system in this world, in this global network, if you wanted to identify the first address, identify the first thing only, you should know about the MAC address of the system. If any culprit is doing some activity from remotely, and if you are able to get that MAC address, it would be easily identify that. The second point, when the MAC address is always, there is some limitation there with MAC address. MAC address cannot forward the packets from network to network. Why? Because MAC address belongs to data link layer. Is almost physical layer and data link layer combination. The MAC address is there. So it cannot be working as a routing address. So it cannot route the packets from one network to other network. But if you look about that, these MAC address is very useful for peer-to-peer devices. That means, let's say take these two devices are connected, this switch. So switch is knowing about this machine and switch is knowing about this machine MAC addresses. Similarly, this switch MAC address is sharing with this firewall. Though the packets, once they are understanding their knows each address, simply they will forward the packets because of they know the address. If any packet is coming, that packet belongs to, that MAC address belongs to this switch, is simply forward this side. The MAC destination MAC address belongs to this switch, simply packets divide. So intelligence it is using, switch is using intelligence. So when this person is contacting or sending a message to this thing, the switch knows that this particular address. So that it never forwards the packet this side, it forwards simply packet this side itself. So some filtering is happening here itself at switch level itself. That is what the point. So like if you take this router, this router is even our router itself, our organization router itself, but we are taking a connection from BSNL. BSNL was also having given some other routers in the peer-to-peer organization where they physically located at place, so that the two routers also talk to each other. This router is Namke Vastava router, but it is a part of internet. So many packets from internet can come here. But so the destination address, after seeing that, it forwards this side, whether it is IP address or MAC address. So it simply forwards the packets other side. That is where the router is works there, because this one. Because IP address is basically the, you know, that is the IP layer, third layer devices where it can forward the packets, routing packets. So we'll see one by one. So what is the MAC address? MAC address is a 48-bit address. See, if this is represented in for the immediately recognizing and remembering with the numbers in hexadecimal format. But if you see that first 24 is talking about the company who designed and developed this particular thing. See, that is where this is the authorized unified identifier of that company. And the remaining 24 bits is basically the unique of that company which developed. So that means it's a 48-bit, 24-bit is the company's name. The remaining 24-bit is basically that unique number. Suppose this series is over, this number would be same, it starts another series. Similarly, if you look into that, these three different networks, this is a MAC address, Apple ka, this is maybe a Dell ka, this is maybe a some other system ka. So we can identify MAC address, which company that belongs to that particular, what kind of device it would be there. So MAC address is used to ensure the physical address of computer. It uniquely identifies the device on a network. Every device connected to either your home network, your office network, has a unique MAC address. If your computer has multiple network adapters, each adapter has its own MAC address. So that is where, so remember it, MAC address is 48-bit, 24-bit is the related to that organization, and the remaining 24 is the uniqueness of this one. And any network card, any physical address, if you are taking, that is unique in this world. Now we look about that, how does internet work? So how basically we all think of that it's in a cloud. So generally we make it, this is a cloud, because wherever you are there, you are accessing your email. Whether you are in Bangalore, you are accessing the same email, but just logging into that. And when you move to Delhi, so your data is available. You move to anywhere in the world, so the same emails will be there available. So wherever you are going available, we all think that how it is coming, the data, as a normal person when he doesn't know any IT background. So it's a simply cloud. But actually, if you look into that, everybody is connected. Even though the continents separated by, and there is no land between these two continents, so still they are connected. So you may, the possibility is maybe one space or otherwise satellite communication, but I don't think so. Everybody is using satellite communication. The wireless technologies won't extend except the satellite connection. So, but see, internet is connected a kind of an line. Everybody was connected to that particular physical lines. So when you are taking in a BSNL site, and if you are clicking www.infosecawareness.in website, what example? So computers doesn't any computer doesn't understand about www.infosecawareness.in, because computers only understand binary address, binary numbers, 1 zeros. Until it knows the binary address of that particular www.infosecawareness.in, it cannot forward the packet. So it should go to the DNS server where it is exerted this one and send that I would like to access www.infosecawareness.in. to that particular infosec awareness, you should be connected to your local area network, or otherwise you should have a public IP address to access this DNS server to get the address of www.infosecawareness.in. Once it gets www.infosec awareness, it goes to reaches one of the web server and get the page. So, but entire thing, wherever the servers are located, co-located, they are all connected. Suppose your server is located in US for a particular website, so you can get the IP address and you can reach by connecting this backbone of this network. So how they connected? If you look into that submarinecablemap.com, you can see that and you can click that. So this is what happening. Let's say we will see that we will submarine cablemap.com. Oh, site is not reached or some problem is there. Google.com. I am typing site name. Submarine cable map. This is one of the website. You can look about that, all the maps. See, look at coming to India. So how India is connected. So recently the Bay of Bengal. Chennai, India. Now there is a separate line recently. Yes, this one. There is a separate line. Port Blair, India. Cable was laid and inaugurated by our beloved Prime Minister of India. So Chennai Andaman Nicobar Island cable. So everything is connected here for continents, countries. So there are a number of lines are there. So if you can see that this is one line talking about that, and most of these are terminated at Trivandrum, Kochi, Chennai, India, and Kolkata and Mumbai. So all submarine cable. So that is where we have to look into that. Now coming to the IP address. So what is that exactly IP address? Because as we learned, MAC address is a physical address, yani our hardware address is only peer-to-peer devices, and within LAN itself it can work. But between LANs also the routers which are connected as a gateway routers of that particular LAN also could be exchanged with the MAC address. But however, one network to another network, you have to route the packets, you need IP address. IP address is logical address. So logically in the software based address, you will give in the software. It's not fixed with any hardware. So that's what we generally called it as a logical address. If any packet is initiated, let's say you are host 1, host 2, the host 2 are talking about host 2 and host 3 is accessing the website of www.cdac.in. So what exactly you may be using HTTP protocol or HTTPS protocol at the application layer. It will talk because you require a web page and you require a reliable connection. You may be using TCP. So that request would be taking at the transport layer with the TCP, and you have to route this packet. So that's what network layer is required. That's what you are taking IP protocol. So from there, this should be connected either Ethernet, because your network may be Ethernet, or your network is a point-to-point protocol based network, and then packets would be sending into the hardware, respective hardware, and the packets will go through like this. And when it is reached, so the server side, it will come to the network card physical layer and understand that what kind of frames and how many frames are came. then take the network header layer, removing transport layer and application layer, reaches the web page, they can send it back like this. So that TCP/IP layers are very much important to transfer this one packets from one place to another place. TCP/IP suite helps, and the entire internet is working on this TCP/IP protocol suite. Sometimes this cdag.in you are accessing in a video, so that only one time only request will come, then from then the number of packets will travel to deliver to yourself. So at that time you may be using UDP. This transport is using UDP protocol only, because there is no reliable connection. All packets I am sending, when I'm sending, the all packets should reach to you, and that whatever video running YouTube or some video streaming, that should run and come back. If something you are missed anyway, you will only request back that, refresh it, and you will get back those packets, so that I don't have required to anything confirmation whether packet is delivered or not. When packet is delivered or not to the remote system, that time only the TCP we use it, but not this one. But when streaming, I'm giving videos, I'm giving, it's your responsibility. If that something is not coming, you may be again sending the request that refresh, so that again I will packet send it. But in the website communication, pages communication, I always look into that whether packet is delivered or not. Once delivered only, I'll try to start the packets continuously. Otherwise, non-deliver packets, again I will resend it. That is what TCP. TCP is a very much reliable connectivity, and the UDP protocol is non-reliable connectivity purpose they use it. So IP is common. IP layer may ICMP protocol is there for testing of the various network internet control messages. Now, if you look into that about this classful IP address, see, as that is 48-bit. MAC address is 48-bit, and in the representation in hexadecimal, and divided into the 6 octets. 6 octets, 6 into 8, 48. Each octet representation with the 2 letters, that means 0 to A, B, C, D, F, 0 to 9, and A, B, C, D, F, hexadecimal for 16. So each bit is 4 bit, and each 2 letters is 8 bits. So that would be divided with the column, so that 6 into 8 bits, 48 bit. But when it is coming to the classful IP address, IP address is 32 bit, and divided by 4 octets with 3 dot notation, separated by 3 dotted notation. Like you, by this time you know that 145.10.34.13. So for our convenience, it is in the decibel system which we are able to tell that 192.168.1.1. But if really speaking that computers cannot understand decimal system, so computers only can understand binary system, either zeros, one. So 32 bits would be represented like this, and by dot notation, this one. That doesn't mean 166.75.29.22. And this entire portion would be divided as a network number and host number, or network prefix or host number prefix, because total is 32 bits. And if you're looking about the dot notation, let's say like this 10, simple example, we'll take it. So these are the representation of 8 bits. How do you calculate? How you get this 10? 0 into 2 power 0. So that means 0 only. 1 into 2 power 1. That means 2. 0 into 2 power 2, 0. 1 into 2 power 3. So 8. So this is a 2 power 4 into 0, 2 power 5 into 0, 2 power 6 into 0, 2 power 7 into 0. So it is a 2 power 0 से start करके 2 power 7 तक रहता है, because the 8 bit, 0 to 7, 8 bit. So but when wherever the ones are there, this is a 2, this is a 8. So that became as a 10. So generally we were able to tell in the binary format 145.10.34.3. So that is where the representation, but actually computers will speak with this material. Now, if you look into that, if you are representing that this entire classes would be divided into 5 classes, class A, class B, class C, class D, class E. And so whenever you represent it into 0, 1, 0, 0, 0 into 8 bits dot, 8 bits dot, 8 bits dot, 8 bits, so total 4 octets. If first octet, if you look into that, the first bit, if it is 0, that is always class A. Because 0 means last 0, 2 power 7 into 0, the remaining things would be there. So if all together makes that, that lies always between 0 to 127 only. So that A class A always belong to 0 to 127. That means first octet is lies between 0 to 127. That is class A. And class B starts, if first octet starts when in a binary format with 1 0, that is always class B. When it became 1 0, that starts, that first octet always belongs to either 128, from 128 to 191. So first octet belongs to 128 to 191. Okay, so that is the B class. Similarly, 110, if first octet starts, that was the class C, and that is belong to 192 to 223. Generally, class D, class C are not defined, but however, the first octet is 1110, that is class D. The first octet, all first 4 bits are 1111, that is class E. Class D maybe they are using for multi-classing, etc. But this is where they define, and most of the people know that. And I request the people to type their address, IP address, what is their IP address and class. So please type your IP address and your class. If you are working in Office, just look into the type about ifconfig if you are using Linux or ipconfig all. So see that what is that IP address. Tell me that what is that IP address belongs to which class. So total in IP addresses, there are 2 power 32 IP addresses are only available in this internet. That means maximum, if you are using IP version 4 network, there is a IP version 6 is there, 128 bit. But when you look into that IP version 4, the maximum 32 bits are there in IP address. So you can create the addresses 2 power 32 addresses only. So it's like a 429 crore addresses are available. That means 429 crore net machines only you can connect it. But if you are looking into the countries like in China, India, US, so there itself is sufficient, not sufficient these IP addresses. That's what they introduced public IP and private IP, and also static IP and DNS IP that we will discuss in the firewall. But when it is coming to the public IP and private IP, so some systems which are made as some IP addresses are added as basically private IP address, so that all LANs can connect these IP addresses where when they connect to internet only can use public IP address. This way they solve depletion problem. So wherever the opportunity comes, I will discuss about this private address and public IP address. So otherwise 0.0.0.0 is the default route used only during the startup purpose, and 127.0.0.0 is loopback. So that is only the testing TCP IP for IPC and local machine. Host all, if everything is 000, that is belongs to host. And if every bit is 1, that is broadcast, local net broadcast. So basically, if you look into that, as we said previously, the network class A, class B, class C, but here is network address is class A is, you just didn't mind about the number because 192 belongs to class C. But telling about that, this one, the first octet in class A is a network address. The remaining 3 octets are the host address. And sending in a broadcast for that network, So this is the 192, and 192, it's not like if you take example as a 10.0.0 is the A class address, 10.255.250.250 is the broadcast. When coming to the class B, see, class B is 172 is the class B, 192 is again C, is wrong here. 172.16, let's say, is the these two octets are network address. Here, the whatever the red thing is showing as a network address, blue thing is as showing as a network. In class A, the first octet is only the network address. The remaining three octets are private host addresses. When it is coming to the class B, first two octets are belongs to network address. The remaining two octets are belongs to host addresses. When it is coming to the class C, this was basically first three octets are belongs to class C address, and only last bit is let's take example of this C. I hope some will are typed this chat box looking that I'll look about the chat. What are their IP address? Okay, 192.168 1.4. Mr. Srinivasan R is saved. See what is the network address in this 192.116.1.4. What is the network address? Anybody? I am typing 192.168.1.100. This is the IP address. Out of this, which one is the network address and which one is the host address? Anybody? Just type. No. Uma Shankarji, 192 is the network. Is anybody correct him? The host address is 8. Yes. Neha Yadav is correct. 192.168.1 is a network address and 100 is host address. So that means in that LAN, all machines are having the common name, common 192.168.1 common. So 1 to 255, 0 to 255 would be the host address. Why? Because in host address, there are 8 bits only there in the C class. The 2 power 8 means 256 hosts only you can connect it. So that means 0 to 255 would be becoming the IP address. Now I am typing another IP address. Somebody other than Neha Yadav or those who answered C class can tell this. What is the network address? Because 172 lies between 128 and 191, so it is a class B. So Kanika Gambhir is has already answered. See, always we should say network address means 172.16.0.0. That is always the better representation of the network address. That's great, Deepaji. So now I am giving A class address. Now A class network address, perfect, Kanika Gambhirji. So that is where we look into that, the network address. So that's perfect. Then we will move on. So total limitation of the class pool addressing is total running out of address space soon. Definitely that's what they bought the IP version 6. Class boundaries did not foster efficient allocation of address space and lack of address class to support a medium-sized company. Why? Suppose let's say in the class C, how many networks we can keep? Only the 254 hosts. If you remember, 0 is the host network address and 255 is broadcast network address. So maximum 254 machines only you can connect it. When it is class B, the 2 power 16 hosts are there. Am I right? 2 power 16 is maybe 65,536. So that host network address and destination network address removes 65,534 hosts. So any company, these many machines, these many IoT devices should have. So that is good. Now my another here is that how many Class A networks are available in this world with respect to the IP version 4 addressing? Anybody? IP version 4 may how many Class A networks are available? How many Class A networks are available? Anybody response? Or shall I go? Yes. Yes. Kanika Gambar has said 2 power 24 and Kishore Jagdap said is 65,534. Remember, but so the answer is Neha Yadav's correct and Deepa is correct. 256, 255, that's okay. So basically, how many bits are there in the network address of Class A? The first octet to only network address in Class A. That means 8 bits are there. So maximum you can have 2 power 8 networks in Class A. So anybody want Class A networks, there are only 256 networks. So when it is Class B, the 2 power 16 networks and each network is having 2 power 16 clients. And when it is coming to the Class C, 2 power 24 networks are available and each network is having only 256 hosts. So perfect. I think we'll move on. So as we discussed it, because of this address spacing is getting soon, that's what they divided these numbers. Remember all these numbers, you please remember when you assess, these questions may come to you. 10.0.0.0 to 10.255.255.255 belongs to Class A address. And 172.16.0.0 to 172.31.255.255 is only the private IP addressing system. And 192.168.0.0, 192.168.255.258. These two, this range is in Class C is also private. So private IP addresses. Okay. So remember it 10.2, 10.250 to a full space, but 172.16 to 172.13. So there could be a 172.17, 172.18, 19 up to 31. That's many networks. You can use it if you have a multiple departments in Class B. 192.168.0.0, 192.168.255.0 is the Class C networks. So basically, as we discussed, network prefix, host number. Subnetting is how do you that? The subnetting number. Suppose let's say this is the network prefix and this is the host number, entire host number. If host number, if you add once at the left side, that can become as a subnetting. That means, let's say your why subnetting is required. Let's say you have a 15 machines. But what is the minimum class you can adapt? C class adapt. When you are adapting Class C, there is a 256 machines. If there is a broadcast message sent, because of 15 machines are there, all 15 machines receives the broadcast message. But the remaining machines are not there, but you have sent in a broadcast. So it will try to deliver the package to until somebody is receiving those packets in a stipulated time. So packets unnecessarily roaming. So 256 machines are sending at a time 256 into 256 into 256 into up to 256 times, your network congestion will happen. So that as much as subnetting is required, so if an opportunity comes, I will try to explain in separate video and host it on subnetting. But please remember that host number could be added and that left side bits if you are adding, because all 250, this is host number. So 172.168, if this one of the number, host number, some part number, if you make it as a network, that would be subnetting. That means this host, I divided into two parts, 256 hosts, I made it as a 128, 128, two subnets. Suppose if I divide into four parts, so that is what is happened, 64, 64, 64, 4 into 64 subnets, 4 subnets. If I divide into 32 part, there is a further, I am 8 into 32, 8 subnets I can create it. If I have a 15 machines, only 16 network as enough, so that I can divide into 16 parts, 16 into 8, that could be 16 into 16 networks, subnets can be created. So what is that? That a subnet number 1 is extended to the network prefix and it becomes as a total network, and this is will be host number. So if you look into that, 130 is 130.5.5. Which class network? B class network. Am I right? Because it is from 128 to between 128 to 191. That's what this is a B class network. Okay. Now this is I made it as a subnet member. So like if we, how do you define that this is a class C, that if as somebody some people already represented by 8. So if your subnet box is 8 bits, that is an A class network. If subnet mask is divided by 16, that is B class. Divided by 24, that is C class. Now this is the divided, this entire part. Actually by default subnet is the mask is how much in B class, only because network address is only the 24 bit. So up to 24, that means 255 258.0 only basically subnet mask. The remaining are host, but this 111s we added, so that so this is becoming is already made a subnet. Even though it is a B class network, anything that you added any number here, so that is definitely subnetting, as there somebody is divided as a subnets. Hope you understood this. So IP addressing and MAC addressing. Then when it is coming to the internet fundamentals, it's very basic fundamentals. But anyway, if anybody is missed in the first class, then we will look into that. When you are in home, what is exactly you do that? You will connect to the Wi-Fi, and your family members also connected to the same Wi-Fi and share it. Similarly, when you are in office, you are connecting to a device, switch device, where these devices are connected to both. Your colleagues are also connected to switch device. But when you want to connect to the internet, either at your home or whether you are at office, you would be connected to gateway device and you will access internet. And of course, in the organization, they may use firewall. Firewall is a device to control your communication, to filter your communication between local network area and external network area, private network area and public network area. Private network means private to your organization, private to your home. So that's what those networks are called, private. When you are accessing internet, you would be part of public. Anybody can come and anybody can see that. That's what public is, public network. So these are all divided into three parts. If you look into that, these devices. Repeaters, layer 1 devices. What is the repeater? Repeater is layer 1 device means physical layer. Physical layer is, as you know, that networks are all works in a minimum length. Let's see if you for example, Ethernet works maximum 100 meters only. That is also generally we say that, but to reach one point to another point 100 meters, you should have a kind of signals, boosting signals. If you wanted to send the packets more than 100 meters, you should have repeater. So repeater is physical device. It only gives the boosting the signals of physical and electrical signals, mechanical signals to forward further some more distance. So that is where repeater will call. So when it is layer 2 device, they're called as the bridges switches. As you know that layer 2 devices can understand MAC addressing, so that they can understand the packets where that to deliver destination side, if they are all connected to peer-to-peer. Because they are all connected in the star mode, star network, so that every device is connected to switch. So they know about that, what their MAC address is. When within the LAN, when they are talking to each other, the packets would be delivered to the right way. Layer 3 devices are router. When suppose this is one network, home network, this is another network, anything you wanted to transfer, so that would be router is required, layer 3 devices. So layer 4 devices is proxies, gateways, where we have seen in the first slide, which is the gateway device firewall, dividing into the 3 different places and all. So this is where we devices infrastructure is very much important, whether it is banking, whether it is this one. What is the difference between router and gateway? Mrs. Kanika Gambhir is saying that. See, as you have seen in the layers, router will work on IP layer. All IP related. The IP main job is that routing the packets from one network to another network. If we have a LAN, let's say example LAN 192.168.1.0, and in the same department you have another network 192.168.2.0, these both are different. If the packets one network to another network, if you wanted to transfer, you required router. In the switching, switch also possible, but that should be a third layer switch where the router capabilities also should have in the switch. Then only you can packet. Gateway is that, see, within the network you are talking each other, within the network transferring, like 192.168.1.0, 2.0, you are able to do with the router. But when you wanted to go to the public network, or for both these two network at a time, and the gateway is that for 90 to 192 to 168 1.0 also gateway is that router, and 2.0 also router. You should have some other departments that is also router. If anybody in these three different networks as being a local area networks, if they wanted to access a gateway internet, so they should be reached to that gateway, like in a proxy server, application server. So which is above third layer, fourth layer, fifth layer type of devices could be a gateway. I'll explain this further in slide. So now before going to the explanation, so now the same concept of public IP and private IP you should understand. Let's say local area network. If we have at our home, let's say basically you may be taking a broadband connectivity, broadband router from any internet service provider. So you are connecting your iPad, iMachine and mobiles or to this one, having the LAN IP. That router, your ISP is giving an own public IP to connect the internet. Am I right? You will allocate a public IP here, and LAN IP are all belongs to here, which is including router is having two IPs. One is LAN IP, which connect to your LAN devices, public IP to connect the internet. Let's just take example, in your apartment, there are 4 or 5 members are there. Same BSNL they are using. So BSNL what exactly gives? The same ISP. The one public IP, static IP on that day will give it to the router, and second public IP may be giving to the router. So ISP same, so that your public IPs are different. Am I right? But here you also using 192.168.1.1, and your opposite gar may be they are also using 192.168.1.1, and another third floor apartment also they are also using 192.168.1.1. Really speaking, if you wanted to connect the three directly, they can't talk to each other because the IP spoofing happening. But they are connected to router. So for them, this is the gateway. For these people, this is the gateway. For this is people, this is the gateway IP address. Suppose any member wanted to talk to this member, first they should reach this gateway, and they have to get this gateway, then only goes to then talk to that, even though they have same addresses. So that is the beauty of the depletion of the, they solve the depletion of the IP problems. As many as missions you connect to private IP address, but when you are coming to the public IP, you required only one public IP to access internet, so that all IP addressing problems are solved. Okay, then when internet is coming, you may be going to the internet with this same IP only. So your internet address is always this only. So because ISP was allocated this address, it remembers whenever you go to the Google responds back, and it delivers back based on this IP address and the respective port number. So their NAT address, network address translation, and port address translation would be used, that we will discuss in the firewall session. So when it is coming to the DMG, so that we will see that. So before going to that, this is the email, let's say. So when somebody is sending this email server, what is that destination port number of this Mindspace email server? The packet will go to this email gateway of that particular organization server. When it is sending, that gateway of that Mindspace email server will be reached and forwarded. So this way we will understand it. So these are the examples I already explained before. So the skipping, somebody like you are using an email, opening an email application, then you are presenting the email in different format, like including JPEG files or attachment. Then session would be there, your e-learning server. Then transport layer will take care of the end-to-end connectivity of that other side email server, and network layer supports to find out best path, and a data link layer may be using, suppose let's say you are using Wi-Fi, I'm using Ethernet. These layers should understand, and physical data is only ones and zeros. So we are using OSA layers, which we already discussed. OSA layers, then simply skim. These are the standard layers. Then TCP adapting these layers in this format. So which we discussed about all the layers in this format. So that is where the routers will work on layer 3, layer 4 devices more on application based like a proxies, network layer, and the data link physical layer. The packets HTTP always travels TCP, ICMP like this and receives this side. And this is what data. So for every data, there would be adding the TCP header, IP header, Ethernet header, and forward it. And when it is receiving side, Ethernet header removed here and forward to this one, and IP header would be reviewed, then TCP header removed, then only the data can see receiving side. It's all discussed. That's what I'm skipping in the past. See, when you are looking at the application side is called data or message. When you added authentication header and data, it is becoming as in a segment. And when transport layer added, then TH added and forwarding it to the IP layer, that becoming as a data. When internet header added and forward to the lower level, that would be becoming as in a frame. Then when Ethernet header and Ethernet trailer added to the data and forwarded to the physical layers, that becomes as a bit. So bit, packet, frame, packet, segment, or the different names where the packet is traveling. So this is one of the 2 or 3 questions you will get in the assessment. The packet, when we mention as a packet, on which layer that packet is, the data is called as a packet. So network layer. The data in transport layer is called segment. The data in data link layer is called frame. The data in physical layer is called bit. So please remember these things. And when the receiving the Ethernet level, either it could be ARP, RLP, IP. If it is whether ICMP or management, IGP. If it is an application, either it takes UDP, TCP, and that respect to application will go to that. So this is called demultiplexing. So our client server communication, if any server, any client wanted to talk to each other, so web browser will be talking to the particular web server. But www.cdac.in, when you say that, it cannot understand, so that it's required in a DNS, domain naming system, where DNS query would be happening. Then an DNS response will get an IP address, then it will be accessing. So ARP request in generally happens first if it is the local side, then DNS will be there. Sometimes the DNS server is because of the this action. Then ARP reply you will get also. This is basically for understanding about what is IP address and what is the MAC address. So then TCP three-way handshake, then only request, HTTP request will be sending. That means when you are typing www.cdac.in to the particular thing, all above things will be happen. Of course, if you have a DNS cache, DNS IP, then directly DNSP can be avoided. By the time you understand ARP request, because of the you visited before itself, so that would be reduced in the next consequent communication may. But three-way handshake is must. Three-way handshake, which we learned in the second day, synchronization packet will be sent to the server. acknowledgement will get to with respect to synchronization, and this one. Why we all learned all these like in a protocol understanding? When you are looking about the infrastructure devices, when you are want monitor your infrastructure devices, when your IDS is working based on this three-way handshake gate. If somebody is doing a scan, like a SYN scan continuously from remote system, how your IDS will recognize it? SYN scan is what? So basically synchronization packet would be sending, server will send acknowledgement if port is running, and then server will be waiting for the this one. But that guy is what they doing? He is, because he already knows about the port, he drops the packet, he reset the connection, and he is continuously doing each and every port. That means he is not coming for the resources. He is only finding about me. So meanwhile, if IDS is there, yeah, this guy is scanning your system, and immediately alert the system administrator, network administrator to block that IP and to reduce the congestion. So IDS ke liye, we required that understanding of the TCP communication. Firewall, if you look about the FTP protocol works on two different protocols. If one is not enabled, FTP connection is enabled, but you are not enabled either one port, then communication never opens. But to test that, you require TCP communication. Anything attack pattern, if somebody is doing denial of service attack, you required understanding of this TCP/IP packets. So TCP handshake happens, then only web page comes. The beauty is that all these things would be in the practice of fiction. You might have collected packets, you might have seen each and every packet within SYN packets within a fraction of seconds you are able to get it. So what are these four layers when I'm coming that? Repeaters are shared layer device. Shared means what? If in repeater is nothing but multi-port, the multi-port repeater is nothing but an hub. So maybe you know very well, in generally in home you use hub only. That means if this guy is sending a message to this guy, this repeater doesn't understand. There is no addressing system in the repeaters and hubs. Where to send it cannot understand, because repeater is nothing but boosting the signals to forward other side. So one point से data आ रहा है, other point से data transfer करने के लिए I am simply forwarding. Other than that, I am not using anything. So this switch doesn't know about that. So the packets are it is sending. What is that? Because of the there is no nothing is known. It forwards to other side. Simply each and every point it is forwarding, copying, forwarding, copying, forward. There are 8 ports. Are there 8? Multiple copies it will forward it to the 8 ports. By whomever this you take it, I don't mind it. That is why forward it. So in case he is sending I love you message or I hate you message, that others also can see that. And even though when you are sending in a Yahoo mail में advertisements आते हैं ना, वो भी देख सकते हैं. If you are able to collect the package through Wireshark and understand the Wireshark. So you are keeping your eye on the communication, what is happening in the network. So, but when coming to the switch is not like that. Switch is basically the A is forwarding the data, A is forwarding to the data B, because switch understand by the time what is the A's MAC address, B's MAC address, C's MAC address, D's MAC address. When A can forward it to B directly, so C and D cannot see that. But when coming to the routers are basically, so when you are dividing, these first two are repeaters and switches are, both two switches are part of LAN, and routers are basically for two different LANs or two different networks. When it is coming to the gateways, when you have multiple connectivity routings are happening like a firewalls and application gateways, all will come that. When you are hosting www, SMT, DNS, so at a time 3 times, so and controlling that, these are all comes under gateways. So I hope you understood these things, and this is where network architecture, where we will look into that hardware. I have taken 6 minutes more. So firewalls, idea says that I request Mr. Nandiswar to join and take these classes. Any questions? Any by the time when he joined, any questions? Any, please? I hope Ms. Kanika Gambhir, the difference between router and gateway, you might have understood. If you have any other questions, let me. Hope Mr. Atul, you got some network basics through this lecture as we discussed yesterday. If no questions further, let me hand over to any doubts of that previous lecture, network concepts.